Hi. We have one more topic I would like to do before you have your test next week. So we have to do a little bit of ratios. Okay. So put this in your table of contents. Um, Ratio review. Okay. It will be on your test. So um, just a few questions though. Okay. So table of contents ratio review. Put today's date, which is January 16th. And let's go. So there's a couple of do nows. I want you to do a few questions. All right, so let's go. Start with this one. Okay. 40 students are in the classroom. 45% of them like pizza. 1/8 of them like hamburgers, and 2/10 like hot dogs. So question A: how many students like pizza? Question B: how many like hamburgers? C: how many like hot dogs? And D: how many like none of those three items? Okay, so press pause, get to work, see how you do, and then press play again, and we'll go over the questions. Okay. All right, so let me just lower this a little bit, and I'm going to do one by one over here. So we have our first question, and let me pick a color. Let's try purple today. And how many people, or how many students, I should say, like pizza? So we can use a ratio because we're given a percentage. So here's my 100 that it's always there. We're given 45%, so we can use that. So 45% obviously goes on top of the 100. And on the other side, the only other number that we're going to use is this one, because there are a total out of 40 students, a certain part of them like pizza, and that's what we want to find out. Now, 40 to 100 or 100 to 40, not really a clear relationship. Okay, I can't divide this by 2. If I divide it by 5, ooh, I can actually do that. If I divide this by 5, I get 9. If I divide this by 20, by 5 again, I'm sorry, I get a 20. There is a relationship here between 20 and 40. How does a 20 become a 40? Times 2. And I'm going to apply the same, multiplied by 2 on the top, and it gives me 18. So if there are 40 students, if I say 45% of them like pizza, that means 18 of them like pizza. So I can write 18 right next to this question over here. Okay, let me erase that. And part B, 1/8 of them. So if there are 40 people, 1/8 of them like pizza. So let's see how I can do this. This one, it's probably easier if you draw it. Something like this. Okay, that means 40 people, and it's cut up into eighths. So 40 people cut up into eighths. 1, 2, 3, 4, 5, 6, 7, 8. So 1/8, another eighth, another eighth, 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 even me. So I got 40 people. Here's my 0. Here's my 40. Here's a 0, and this is 1/8, 2/8, 3/8, sorry, eighth, 4/8, 5/8, 6/8, 7/8, and 8/8, which is 40. So I want to find out what 1/8 is. Well, from here to here is 40, and I'm cutting it up into 8 parts. So 40 cut up by 8 means that every box is 5. So this would be 10, 15, 20, 25, 30, 35, 40. So 1/8 is equivalent to how many kids? 5 kids. So I can write that down here. Next question, question C, said 2/10 of them like hot dogs. Okay, so again, I'm going to draw and use the same thing, but instead of cutting them into eighths, I cut them into tenths, because it says this is 0, that's 10. I'm sorry, that's 40, and that's 0, and that's 10 over 10. So I want to cut up the 40 student into tenths. So here's my 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so if I have 40 students and I divide them into 10 groups, I want to know what these two would be. This is 1/10. This is 2/10, 3/10, and so forth and so forth and so forth. I'm not going to write them all because not necessary. We're interested in only the beginning. So 1/10 to 10. So how many students do 2/10 represent? So, but if I have 40 and I'm breaking them into 10, so 40 broken up into 10 pieces means that every piece, 40 divided by 10 is 4. Another 4 would be 8, another 4 would be 12, another 4 would be 16, blah, 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 until we get to 40. So as far as we're concerned, and we're interested here, we're interested in 2/10. 2/10 means 2 boxes, or it would mean 8 kids. Okay, so question C is 8. Now, it says how many people like none of the 3 items. Well, I know that 18 like pizza, plus 5 that like the hamburgers, and plus 8 that like the hot dogs. That would give me, let's see, 18 plus 5 is 23, 23 plus 8 is 31. So 31 kids, they like something. So to find out how many don't like anything, I would take the 40 that I have, minus the 31 who like something, giving me 9 kids who like none of the 3 items. Okay? Next one. Determine if each is true or false. Explain how you came to your conclusion. Use a number line if necessary. That's probably the easiest way. So the first one says negative 4 over 9 is less than negative 5 over 7. Is that true or false? And the second one is negative 3.76 greater than negative 3.86. I will use a number line to make my life easier. So I'm going to draw the first number line. So you guys, I'm sorry, press pause, figure it out, come to a conclusion, write what your reasoning is, and then check up with me. Okay, press pause, and then press play when ready. So now that you're done, let's do the first one. I'm going to draw a number line at the bottom here. Okay, very, very ugly number line, but nevertheless. So I'm going to put 0 here. And we don't care about the positive numbers, so I gave the negative side a little bit more room. Well, negative 4 over 9 and negative 5 over 7. What's my problem? Well, one of my problems that I have is that they both, they don't have the same denominator. So it's very hard to compare when they're different. Okay, and it's obviously much easier if they have the same denominator. So let's change them. Okay, negative, negative. Let's change them so that they have the same denominator. So think of a number that both 9 and 7 go into. So we're talking about LCM, least common multiple. So you can list the 9 and the 7 and go 9, 18, 27, 7, 21, 14, 28, and keep on going until you find a number that's common to both. And you'll find out, and hopefully everybody finds out, that they share a 63. 9 goes into 63, and 7 also goes into 63. So how did the 9 become a 63? 63? It was times 7. Therefore, I have to do times 7 on top. That gives me 28. How did the 7 become a 63? It was times 9. And times 9 on the top, giving me 45. So now I still have both with the same denominator, but I still don't know who is greater than the other one. Okay, so here's 0, here is 1, negative 1 I should say. Okay, so if I'm at 0, and I'm going to be here, and I cut the space between 0 and negative 1 to 63 pieces, okay, so I'm going to walk, and this would be, right here, would be 1 over 63, negative 1 over 63. The next one would be negative 2 over 63, and on and on and on and on. So if I'm walking, I hit negative 1 over 63 first, negative 2 over 63, then it would be negative 3 over 63, negative 4, so on, negative 5, negative 6. And the first number I'm going to hit is negative 28 over 63. And the second number I'm going to hit is negative 45 over 63. All right, they're not, I didn't put them in the right locations, but that would be the order in which you would hit them. You would first walk upon negative 28 over 63 and then negative 5 over 63. Okay, so now you got to decide which one's bigger. So I'm going to put a circle around each number. Remember what I told you? Anytime you're comparing two numbers, the number closest, or the number to the right, in this case, this number right here, on the right side is always greater than the number on the left. So this is the number on the left, and this, I'm going to change that to an R. That's the number on the right. So the number on the right is always greater. Why? Because it's closer to 0. So here the statement was that this first fraction, which is negative 28, is smaller than negative 45 over 63, and that is obviously not true. Negative 28 over 63 is greater than negative 5 over 63. Okay? The number on the right is always the larger number. Okay? So that's that. And then let me erase this, and we're going to do the second part. Okay, so the second one says negative 3.76, and again, I'm going to use a number line for this. Okay, so this is my 0, this is my negative 1, this is my negative 2. I'm going to make this negative 3 and negative 4 over here. All right, so again, let's take the first number, negative 3.76. If you're a 0 and you're walking, so you're walking, you hit negative 1, excuse me, negative 2, negative 3, negative 3.1, negative 3.2, negative 3. You're going to hit negative 3.76, which is about here. And as you keep on going, you eventually hit negative 3.86. Circle that guy. I'm going to circle this guy. So which of these two numbers is on the right side? This guy's on the right side. This guy is on the left side. So the number on the right will always be the bigger one. Okay? So in this case, it says that negative 3.76 is greater than negative 3.86, and that is a true statement. And I just proved it to you using a number line. Okay? Another way you could have said that is that when dealing with negative numbers, the smaller the number, the greater its value, okay, because it's closer to 0. And then we have this order from least to greatest, okay. So it does help if you put it on the number line, okay. So I would suggest you do that. And then you can see which one is the greatest or not. And press pause, okay, and press play when you're ready. So I am drawing a number line, and I'm drawing a number line that is not enough. So let me fix that at the end. And I hope you drew one too. So let me go down here. I'll put 0 over here. 1, 2, 3, and then negative 1, negative 2, negative 3. So I'm going to put letters under them, so it makes my life easier. And that's what I'm going to label my number line. Okay. So let's start with negative 1.7. Where would I put negative 1.7? So here's 0, here's negative 1. So the number is growing as I go to the left. Negative 1, negative 1.1, negative 1.2, and eventually I hit negative 1.7, which is about here. So I'm going to write a letter A here. B was 0, easy enough. It's right here. C, 2 3/4. Here's 2. And 2 3/4, you could have changed that to a decimal, means 2.75, and 2.75 is about here. And now I'll write letter C. D, negative 7 over 5. You should have changed that to an improper fraction. Okay, negative 7 over 5 is 1, negative 1 I should say, and 2 over 5. Okay, that was an improper fraction. Change it to a mixed number. And that gives you negative 1 and 2/5. Negative 1 and 2/5 would be negative 1. And 2/5, you could have changed that to a decimal. Okay, and that would have given you negative 1.4. And that is somewhere around here. That's D. And finally, letter E, 2.6. That was 2. 2 3/4 careful here. 2 3/4 was 2.75. Okay, this is 2.75. So 2.6 is a little bit less than that, somewhere around there. So there is my order. So the smallest number is A, which is negative 1.7. The second smaller is D, which is negative 2 and negative 1 and 2/5. The third smaller is B, which is 0. The fourth one is E, which is 2.6, and the biggest number is C, 2 and 3/4. Okay? All right, so that was like your 3 do now questions. Okay, so let's talk about ratios and the word problems that we dealt with not too long ago. First question, the ratio of cats to dogs is 5:2. If there are 35 animals in total, how many dogs are there? All right, so I'm going to do this in all 3 ways that we did in the past. Okay, so hopefully, and you can pick whichever one. So take 2 seconds, press pause, do whichever method you remember or you're comfortable with, and then come back, press play, and we'll see which one. We'll see all of them and see whatever you prefer. Okay. So the ratio of cats to dogs is 5:2. So it means that if I have 5 cats, I'm sorry, 5 cats, I have 2 dogs. Okay. So every time it grows, it always grows the same way. So if I draw another group, that next group is going to have 5 cats, 2 dogs. I draw another group, I'm going to have 5 cats, 2 dogs. Okay, ratio is a pattern. It's something that happens over and over and again, but the same way. 5 cats, 2 dogs. Let's see what I have here. I have 5 cats, 2 dogs, that's 7, plus another 7 is 14, plus another 7 is 21, plus another 7 is 28. So I don't have enough yet, so I need to draw one more. 5 cats, 2 dogs. Now I have a total of 35 animals. And within these 35 animals, I want to know how many dogs there are. Well, there are 2 dogs here, 4, 6, 8, 10. There are 10 dogs in total when there's 35. So that was one way of doing it. Another way of doing this, and we're going to do a proportion. The one proportion that I know is that there are, not here, careful. This one's, you have to be careful one here. The one number I know, and I'm going to start with this one, 35 in total. There are 35 animals, and I want to know if I have 35, how many dogs. So I'm going to write dogs here. Okay, now if you go ahead and write 5:2, you're going to run into a problem. Because 2 is not the total number of animals, and 5 is not the total number of dogs. So that will give you an incorrect proportion here. So the number of dogs that we know there are 2 dogs. So 2, and I'll write dogs. Remember, it always has to match side to side. If I write dogs here, it has to be dogs here too. Bottom, the denominator, is a total. Okay, so here, what's a total in that ratio? It's 5 and 2, which is 7. So that means that every time there are 7 animals, 2 are going to be dogs. And you can see here, in each circle there are 7 animals, and in each circle 2 are dogs. So here's how you set the proportion. Relationship, 7 times something is 35. In this case, it's times 5. You apply that same thing on the top, and you get 10 dogs, which is the answer we got using the pictures. Third method, we're going to use table here, and that's not how you do it. So let me erase that. Button there, button there. Okay, so hopefully you remember. So I'm going to write dogs, cats, okay, and dogs for, let's see, I reversed it, so I'm sorry. Let me write, I should have written cats and dogs, so the order matters, remember. So this is cats, this is dogs, so ratio is 5:2, so it's 5 cats. I'm going to make 1, 2, 3, 4, 5. 5 cats, right? And then how many dogs? 2. All right. So each dog represents one single animal. So one cat, one cat, one cat, one cat, one cat. There's 5, and one dog, which is 2 dogs. Now, we want, what happens when there's 35? Remember, when we create a little table like this, okay, one of the things that we know is that each box always contains the same number. So if I have 35 animals in total, how can I put 35 into 1, 2, 3, 4, 5, 7 boxes? You would have to put 5 in each box. Okay, remember that? So what's our answer? So when there are 35 animals, how many dogs do we have? We have 10. So in each question or each method that we did, the answer was the same. It's up to you to choose whatever you're comfortable with. Okay? I forgot the name of the last one. It'll come to me. Well, let's do one more, or quite a few more. The ratio of cats to dogs is 3 to 1. If there are 8 dogs, how many cats are there? All right, so again, let's do this. So press pause. Okay, your memory should be refreshed a little bit. Choose any of those 3. I will do all 3 again. Okay, press play when you're ready. So the ratio of cats to dogs is 3 to 1. So 3 to 1, which means 3 cats, 1 dog. Right? So what happens when there are 8 dogs? Well, 3 cats, 1 dog. So far I have 2 dogs. Let me create another one. 3 cats, 1 dog. That's 3 dogs. Not enough. Sorry, that's a cat. Dog. 3 cats, 1 dog. 3 cats, 1 dog. 1, 2, 3, 4, 5, 6. 3 cats, 1 dog. 3 cats, 1 dog. So now I have 1, 2, 3, 4, 5, 6, 7, 8. 8 dogs. So what happens when I have 8 dogs? I have, let's see how many cats. 3, 6, 9, 12, 15, 18, 21, 24. There are 24 cats. So using pictures, you can come up to the answer. Using a proportion, let's see if we can. All right, so what do we have here? If there are 8 dogs, okay, so let me write 8 dogs over here. I want to know how many cats are on top. Well, the other numbers that we can use here is the ratio that we're giving. And this time we can use that ratio. So cats to dogs is 3, so cats is 3. So every time I have 3 cats, I have 1 dog. That's given to us. How does the 1 become an 8? It's times 8. How does the 3 become an 8? And we apply the same to the top, so you get 3 times 8, giving us 24. Okay? And then we're going to use our tape diagram. That's what it's called. So again, cats and dogs. Cats is 3. 1, 2, 3. And dogs is 1 box. Okay, so what happens in this case? We are given that there are 8 dogs, so this is easy enough. We're given that there are 8 dogs, and you know that once we find the number for 1 box, they're all the same. So this is 8, this is 8, and this is 8. So how many cats are there? 8 times 3, 24 cats. Okay. Next. The ratio of apples to oranges is 6 to 5. If there are 99 fruits in total, how many apples are there? Again, copy, press pause, and then, we have 2 more. Yeah, 2 more. Okay. And I'll do all 3 again when you come back. All right, so ratio of apples to orange. So 6 apples, 5 oranges. Okay, I'm going to do 6 apples, 5 oranges. 6 apples, 5 oranges. 6 apples, 5 oranges. I should have used these smaller numbers. 6 apples, 5 oranges. Okay, 6 apples, 5 oranges. This is not enough because I need to have 99 fruits in total. 6 apples, 5 oranges. Okay, I'm very close. I know group was of 11. Okay, so I need to do 1, 2, 3, 4, 5, 6, 7, 4, 5, 6, 7, 8, 9. Oh, okay, so I have more than enough. Should have stopped here, because now I have a total of 99 fruits. So because each group is 11, 11, 22, 33, 44, 55, 66, 77, 88, 99. There are my 99 fruits. So I want to know how many apples are there. Well, I have 6 apples in each group, and there are 11 groups, so there are 66 apples. Okay. If I use a portion, let's see what I can set up. Let me set up what I don't know. Well, what I don't know is that when I have 99 fruits in total, I don't know how many apples are there. Apple. So let's see what I do know. Well, I do know that there are 6 apples every time there are 11 fruits. Okay, so from here, I find a relationship, and this is times 9. Something wrong. 1, 2, 3, 4, 5, 6, 7, 8, 9. This should have been 99. Wait. Let me 1 second. All right, I know what my mistake was. Here is 6 apples, and 6 times 9 groups is 54. So back to this, 11 to 99 is times 9, and this is times 9, and this is again 54. If you did the tape diagram, let's see, apples is 6, so I hope I can do a 6 here. 1, 2, 3, 4, 5, 6 boxes, 1 for each apple, and it says oranges is 5. 1, 2, 3, 4, 5. That's our initial tape diagram. Okay, so ratio of 65. There's 6 and 5 and 99 fruits. So I have a total of 99 fruits, and I want to put them all in these boxes. Each box would have 9 actually, not 11. I'm sorry. 9, 9, 9, 9, 9, 9. Okay, because there are 11 boxes, and 99 divided by 11 is 9 in each. So how many apples do I have? I have 9, 18, 27, 36, 45, 54, total of 54. Okay. One more. Ratio of pens to pencils is 9 to 5. There are 45 pencils. How many pens are there? Press pause. Okay, so by doing the pictures, I can do 9 to 5, and this is not going to work. You can stop right now because my numbers are wrong. Okay, so that's not going to work. And I'm going to switch this number. Okay, and let's make it simple so we don't have to draw something. Let's make that 42. Okay. So again, sorry, I don't want to cheat. I hope you. Alright, so making that 42, I have 9 pens, I'm sorry. 9 pens, 5 pencils, another 9 pens, 5 pencils, and another 9 pens with 5 pencils. Okay, my initial ratio. And then I kept growing it, and I applied the same ratio again. So each group has 14. There's 14 here, plus another 14 here is 28, plus another 14 is 42. So when I have a total of 42 pencils, which is, again, I'm doing this incorrectly because I'm not reading the question. You know what? We're going to skip this one because apparently I'm wasting time on this one. Actually, you know what? I'll do it. I'm sorry. You know what, let's just do it with a proportion. How's that? Okay, so here is my proportion. I want to know what happens when there are 42 pencils. How many pens do I have? That's the question. So let's see, the proportion, pencils is the bottom, right? So 5 pencils, that's what I'm given. So every time I have 5 pencils, I have 9 pens. actually, oh my God. Ignore this question. All right, the other thing we have to do is rates. Okay, so this is a simple question. Let's see what you remember. Press pause, come back to it. All right, so here, I left you a hint. Money usually goes on top. Okay, hopefully you remember that. It doesn't have to, but I like it when money is on top. It makes life so much easier. So let's write the ratio first, or the rate. Rate is written as $3. I get 5 apples. I want to change that. I want to. Ugh. Seriously. All right, let's leave it like that. All right, so I want to change that to a unit rate. Okay, so remember, to a unit rate, I have to. It means that we're comparing something to 1. Instead of 5, we're making the denominator 1. So we want to know, in this case, the price for 1 apple. So how does the 5 become a 1? It's divided by 5. And therefore, I divide the top by 5. Okay, and 3 divided by 5 means that each apple costs you 60 cents. Okay, and that's how we find unit rate. Remember that this is a rate and this is a unit rate. Okay, fancy name. Unit rate. All it means is that the denominator is 1 because we're comparing it to one single item. Okay, let's see where we used this in the past. So here's an example. Oh, actually, forget it. Take these two as practice. Change both of them to unit rates, please. Okay, press pause, take a couple of minutes, or not even, and come back. So first thing you should have done is written it as in a fraction. 75 miles, 5 hours. We want to change this, and instead of 5 hours, we want to know what happens in 1 hour. So from 5 to 1, it's divided by 5, and obviously the top is divided by 5, which is, I have no idea, 15 miles. So in 1 hour, 50 miles can be covered. Next question. 280 tickets were sold in 15 days. Okay? So we want to change that. Instead of saying 15 days, we want to compare. We want to find out what was sold in 1 day, every day. So you're going to divide both top and bottom by, in this case, 15. 15 divided by something is 1, and it's by 15. And 280 divided by something, divided by 15, I'm sorry. So that's not going to give you a nice number, actually. It's going to give you a decimal, a non-terminating decimal. So you could have rounded. Hopefully you round it to a nearest hundredth. You can leave it as 18.67. Okay. So remember I told you, anytime we're dealing with decimals, at least with me, you know, if it goes on forever, just round it to the nearest hundredth. Okay. So that's how we find the unit rate. Now let's see what it's used for. One of the uses is something like this. Is it better to pay $5 for 8 pencils or $8 for 12 pencils? So I don't know. But by finding the unit rate for each, we can compare and then determine which one is the better buy. So take, like I said, take a couple of seconds, take a couple of minutes, and then come back and let's see if you got it right. Okay. So for the first one, I would write $5 here, 8 pencils. And the second person here, second item here, you paid $8 and you got 12 pencils. So which one was better? Well, we want to find the unit rate for both. So here, we want to find the cost for 1 pencil. So 8 to become 1 is divided by 8, and 5 divided by 8. And you might have gotten, I don't know why I picked these numbers, probably because it's very late. But here is my cost, 0.63. You probably, if you're using a calculator, you probably got 0.625, but remember, money doesn't go to 3 decimal places, so you're going to round that to 6.3. Okay, here, 12 pencils is what you bought, but let's see how much one pencil cost you here. And it's divided by 12, 12 divided by 12, and 8 divided by 12. Both top and bottom have to be the same. So 8 pencils divided by 12, I'm sorry, $8 divided by 12, and this one was again, a decimal that went on forever, 0.66666, and on and on and on. So you're going to round it to the nearest hundredths, and you get 0.67. So where was it cheaper? This guy right here was the better buy. Okay. Next one. Find a better deal for orange juice. By now, if you're using a calculator, this should be really, really easy. All right, so then let me just space them out a little bit. You do the same. Keep working, and press pause if you need to, and I will set it up. So, okay, 8 ounces for $1.09, and again, the first step you should take here is always write it as a fraction. So I'll write $1.09 over 8 ounces. I'll write the second one, which is $2.40 over 20 ounces. And we have finally $4.25 for 30 ounces. So where is the better deal? So I'm going to change everything to 1 ounce here. This one also 1 ounce. And first one also 1 ounce. So by finding the unit rate, we can see which is the better deal. So here was divide top and bottom by 8. Divide by 8, and I'm going to tell you the truth, I'm using a calculator. So that would give me rounded, okay? Rounded would be 0.14 cents. It was 0.13625, but money, like I said, only goes 2 decimal places. So rounded to the nearest hundredth is 0.14. Next one, 2.4, and we're going to divide that by 20. This one was 0.12 cents. Okay, you divide this by 20 to get 1, and then the top by 20. Here you're going to divide bottom by 30 to get 1, and the top by 30 as well. So 4.25 divided by 30 gives me a magic number of 0.416, and round is 0.14. So it's a tie between this guy and this guy. So if you went to the supermarket and you bought, actually, I'm sorry, what am I talking about? The cheaper one, cheapest one is the middle one, 20 ounces. Here, every ounce of orange juice right here costs you 12 cents, and that's where you got the better deal. Okay, so that's that for that, and then we have one more. Jill can run 8 miles in 5 hours. How many miles can she run in 15 hours? You will set up a portion for this one. Okay, press pause. Take a couple seconds, minutes. All right, so here we have our proportion. What do I know? I know that she can run 8 miles in 5 hours. And I want to know what happens in 15 hours. This is really, really easy. Okay. So, find a relationship. It's times 3. So the top is times 3. The answer is she can run 24 miles. Okay? Very simple. Next one. This one's a little bit different. Remember, we had 8 cakes where there need to be a couple of things here. So let's write what we know. Or actually press pause, try to do it. Come back when you're ready, or when you think you're ready. Don't take too long if you don't know how to do it. It's okay. We have a couple more after this. All right, so Jill can run 10 miles in this case in 4 hours. So let me write 10 miles and in 4 hours. And we want to know how much she runs in 22 hours. Now, there is no relationship here. 4 to 22, not something None that I know of, whole number wise. So here, what we have to do is change it. We're going to change it to a unit rate. Remember we changed this? Okay. So instead of 10 miles over 4 hours, let's change that. And I'll write it here in the back, unit rate. Okay, so let's see what she does in 1 hour. So 4 to go to 1 is divided by 4. And then I have to do the same thing on top. And 10 divided by 4 is 2.5. So now I can use this guy here to find 22. So let me write it again on the side. So I'm going to use the unit rate, which was 2.5 miles in 1 hour. And 1 hour. And the other side was 22 hours and blank on the top. So 1 hour to get to 22 is times 22. And obviously 2.5, it's going to be multiplied by 22, and that's easy enough. Okay, so that's going to be, I have no idea, 2.5 times 22 is 55 miles. Okay, so this was one occasion where our initial ratio here, 10 miles over 4, wasn't really that helpful because there was no relationship between 4 and 22. So I figured out what the unit rate was, and I used the unit rate to find my answer. It's just like when you're doing the percents, you're either simplifying or amplifying or making it bigger, okay, because the numbers doesn't work with 100. So it's the same thing here. Okay, so try this one on your own. And I believe this might be our last question. Good, because my battery's dying. Okay, press pause, come back. So all right, so you're setting this up, and you're given that she can do or drive 84 miles in 7 hours. And you want to know how many she can drive in 16 hours. And that's where the question mark goes. All right, as it is, I am pretty sure nobody found a relationship between 7 and 16. Nothing works with 7 and 16. Nothing times 17 will give you 16. I highly doubt it. Even if it's a decimal, it's not going to be a nice decimal. Yep, it's going to be a decimal that goes on forever, non-terminating decimal. So that's not going to work. So we can't change the blank over 16 hours, but we can change the 84 over 7. Okay, instead of using 84 over 7, so in this case, let's find the unit rate. So on this side, instead of saying she drives 84 miles in 7 hours, let's find out what she does in 1 hour. Can we do that? Yes, we can. 7 to go to 12 to 1 would be divided by 7. And then on the top, you have to do the same. If you divide the bottom by 7, you divide the top by 7, and 84 divided by 7 is 12 miles. So there is our unit rate, and that's what we're going to use in this problem. So let's do the problem again. On this side, question mark over 16 hours. And instead of using 84 over 7, we're now going to use 12 over 1. And pause. All right. So we're going to use 12 over 1. So what does that give us? So relationship between 1 and 16. 1 to 16 is times 16. Therefore, top is times 16 as well. And 12 times 16 is this beautiful number, 192. So if she were to drive for 16 hours, she can drive, or she can go up and down. That's very nice. She can drive 192 miles. Okay, so there's your little review on rates that we did not too long ago that you will need to know for the test on Tuesday. Okay, I will put this on the class website as well. If you need to review it, it's there. Okay, and that's that for this.